simple beam. We have already seen what is simply supported beam, right? In class we have taken it. So if you take such beam, so we have experimental setup there. So simple beam, what we are going to see for this experimental setup, we will be first measuring what is the length of the beam. Okay. So if you see the table, and then we will see what is self-weight of suspender, means we will be attaching load here. Okay, some suspender is there. So we will see what is the self-weight of that suspender as well, and whatever load we will apply. Say this load is 1 kg. Suppose if this load is 1 kg, and if it is in the middle, so what will be the reaction by common sense? It has to be half, right? It will be taken as half. So 500 grams here and 500 grams here should be taken care. Okay, so this is a simple concept. So what we will be doing, initially we will see, and we will be having some scale here. We will see that we are getting the correct readings. Then we will apply load at some point here, which is at symmetrical. We have two columns or two rows here, symmetrical load and unsymmetrical. So say this is your W, then let us apply W1 here and W1 here. For example, if W is 1 kg, then W1 and W2 or W1 can be again say 1 kg or it can be 2 kg also. If I write here as 1 kg and if I write here as 2 and if I write here is 2, still it is a symmetrical position. Okay, so this is one case. Then like this we have to take the 3 readings for symmetrical loads. Okay, so that we will do, and then we have to do for the unsymmetrical load. Means we will shift the positions of load, and every time we will see what is the corresponding reading. Okay, so for symmetrical you know what is the reaction, that it will be equally distributed. But for unsymmetrical we have used the equation, equilibrium condition. So see the aim of the experiment to verify the conditions of equilibrium. Okay, so what are the equilibrium conditions? We will see that summation of forces in y direction is 0, summation of forces in x direction is equal to 0, and moment is equal to 0. So we have to verify these conditions. So whatever practically we know what are the distance, what are the loads, so we will actually calculate what is the reaction at A and B. We will also see that what is that our experimental setup, what is the reading we are getting. So both we will verify, we will find out the percentage error. Okay?
Yes.
Kept properly. And this is a suspender. Initial weight of the suspender we will take. What is the weight of it? And then whatever load we are going to apply. Simple step that if this is 1 kg load. So if you apply here, initially you have to take the reading here. That let's say this is RA and RB. I am standing like this. So the left side as per in table, RA is left and RB is right. Okay. So for me this is RA. So RA, if you take the reading, now there is some error. So let's say whatever reading you are getting, note down RA and RB. Okay. So that you will note down. Then add weight. So if this is 1 kg, you should get the reading as 0.5 kg and 0.5 kg. Okay. So this is one thing. First we'll do like this, and then we will add some more loads. So now if this is in the middle, yes. Oh, sorry.
ऐसे होना.
So now if we see the symmetrical case, so in that, if this is the middle, so just see 1, 2, 3, 4, anything, suppose this is fifth, so I am putting this here, 1, 2, 3, 4, 5, so add this suspender here. Now you add the weights, so here say 1 kg, then add, this is how much, 2 pounds, so you have to convert it into kg, this is also 2. Okay, so total weight you have to see in kg, and then the reaction should be again symmetrical. So this way we have to take 3 readings and then make it unsymmetrical. Means just change the position. Yeah, every time to make it as symmetrical, you have to first you have to properly measure the length of the beam. Then what is this distance? Because we need all this distance. right? To calculate reactions when you do the manual calculation, and that is for symmetrical and unsymmetrical both. Okay, so see here, even for symmetrical you have to do the manual calculation and show the reaction. Okay, so this is unsymmetrical. So like this also you have to take 3 readings and match these readings with whatever your manual calculation. Okay, so this will be all.
Thank you, teacher.
Show this as a, because we have already studied such things. So let's consider two loads like this. So let's say this load is 10 kilonewton, say 20 kilonewton, say 15 kilonewton. Okay, so this is the beam. And here there will be some reaction. You may say it as RA or VA and RB. Now we are ignoring here the horizontal reaction because all loads are vertical only. Okay, let's take this distance as say 2 meter, 3 meter, 2 meter, 2 meter. Okay, so these are the lengths we have taken. Now when you do the calculation, okay, analytical, you know what will be the calculation, so that you can easily find out the reactions for this by calculating moment and all. Okay, considering moment, do the summation of forces in y direction. Then when you consider moment about A, so you will be able to find out what is RA and RB. Okay, so this procedure you are already aware. Now how do we draw the space diagram and then the funicular polygon? So what we do, we use the Bose notation. Okay, so we name the spaces, we actually use the spaces. Okay, here you can see that there is some space between A to this load, then this particular load to this load, there is a space, so we use spaces. Okay, so let's use those notations. So let's say from support A, this is a support A, this is a support B. So we see that from support A to this particular point load, what is acting. Okay, I'm purposely not giving names here because you know these notations, we have to use a few alphabets. So that's why I'm just, I'm going to use A, B, C, D here. So I'm just ignoring this. You can give some names here. So now, or let's name it as, say, let's name the beam like this. Let's call it as PQ. Okay, let's call it as support P and support Q. So it will be RP, RQ. So then PQ. So we may call it as RST. No problem. Okay. Ha. Now let's see what is the space between R and S. So let's name. Okay, so this is space between, actually we have to see like this, reaction to the load. Okay, what is the space? So let's name the space as A. Okay, A is the space. Let's name the space between R and S as B. Let's name the space between S and T as C. Let's name the space between C and Q as D. Let's name the space between Q and P as E. Okay? So let's do this initial part. Now, we will have to draw some diagram here. Okay, there will be some diagram. It will come after some time. So what initially first diagram we are going to draw, that we are going to draw it in this side. Okay, so the first we'll draw the space diagram, then we'll come to the funicular polygon. Now let's see, now let us decide the scale. Okay, so scale, we have to draw graphical diagram. So scale, let us decide that, is your wish, what scale you want to say. So let me consider 5 kilonewton is 1 centimeter. Okay, so you need a roller scale for this. Okay, what is that? Roller scale is very important because we have to draw parallel lines here. So if you see the now you see A to B. Yeah, one more thing, see that it is in clockwise direction. Okay, what notation we have given is in a clockwise direction. So A to B, if you see, it is a 10 kilonewton acting in the downward direction. So what you will draw, 10 kilonewton will be 1 centimeter. Sorry, 2 centimeters. So draw a 2 centimeter line and say here A to B. Okay, A to B we are drawing as 2 centimeter. Then we have to draw B to C. So B to C will be 4 centimeter. So from B to C we have to draw 4 centimeter. Then C to D it is 15 kilonewton. So it will be 3 centimeter. Okay, so once you are done with this, then we have to take, okay, we don't have to do anything about what is D2A and E2A because we don't know their value. So we are not drawing it now. Okay, once you have done this, now just take any point O here, any point. There is no specification that you have to take it in the middle or anywhere. Okay, so just take randomly one O point. And now just connect all these lines. Okay, so this is our, we call it as a, this is not completed. Okay, it is called a space diagram or vector diagram. Okay, so this one diagram we have done, which is not complete. We have to also include the reactions. That part also we'll see. Now if you see from D to E, there is a RQ reaction, right? There is a RQ reaction. So we'll see that D to E, how do we draw? So from D point to E point, okay, that is the reaction over here. So that we have to draw. So before that, what we will do, first we will draw the funicular polygon. Okay, so funicular polygon, now if you see here, OA line is there. So OA line, okay, this is OA line. Here is the A space. So what you do, take your roller scale, draw a line parallel to AO to the A space here. Okay, यहाँ पे randomly आप एक approximately line draw कर लो, ठीक है? So here it should be parallel to OA. Okay, it should be parallel to OA. So I am using it approximately, but you have to draw it by the scale, okay, to get the correct answer. Now there is a B space. So for B space, at the B space, you have to draw OB. Okay, draw a line parallel to OB. Take this line here, here, bring it here, okay, and draw the BO. Okay, now there is a line CO. So CO, and there is a C space. So draw a line parallel to CO. Then DO and D space. Draw a line to. Okay. Now this is all the lines we have drawn. Now we have to close the polygon. Close it. So here we have closed the polygon. Okay. So this polygon, it is between P and Q. Here when we have closed it, okay. So what we have to do, we have to draw a line parallel to, okay, this line. Okay, we have to draw a line parallel to this line from O point. Okay, so what you do, so it should come parallel to this particular line. Okay, these two lines are parallel. So draw it parallel like this. So you got some reference line here. Okay, you got some reference line. Now what you do, draw a straight line at Q point. Okay, Q point we have to draw a straight line. So here what we'll do, we'll draw a straight line. Now it may not be. Now what is happening in this case, that it is meeting at the same place. Okay, when you draw by the scale, it may or may not meet at the same place. Okay, it may go somewhere right or left also. Okay, so just be careful at that point, because now this is approximate diagram. So what is happening, my Q point is getting here. Okay, so DQ. So if you see, not DQ, sorry, it is a DE. This is a DE. If you see DE point, DE, D is nothing but the reaction at Q, right? DE is the reaction at Q. And then there is a EA, okay, EA. So EA, now because there are all vertical loads only, so here EA is a reaction at P point. So EA is equals to reaction at P point. Okay. Now what you will do, you will measure this length, measure this length RP. Measure the length and check your answer with the answer if you get it here. If both the answers are matching, okay, if both the answers are matching, that means your graphical analysis is correct. Okay, so that is a good validation. Okay, so this is one case. Then second case, let us see if this is a beam, and here again it is a simply supported beam. So here there is one load here, there is one point load here. This is at some angle. Okay, so here it is an inclined load. Okay, let's say this angle is 60 degree. This is say 15 Newton. This is 10 Newton. This is A point, or again we'll take it here as a P point and Q point. So here again, let's first let's say it has 2 meter, 4 meter, 2 meter. Okay. Now again start with the Bose notation. So let's call it as PQR. Sorry, Q is here only. So let's say R and S. So let's name the spaces A, B, C, D. Now here, because it is an inclined load, so there will be some reaction, right? And because this load will have two components, so there will be a horizontal reaction as well. Okay, so let's say VP, HP. Now here A, B, C, D, but because there is a horizontal reaction here, okay. Now in above case we did not consider that because only vertical loads were there. Okay, so horizontal reaction is anyway zero, but in this case it is there. Okay, so this space also we have to give the notation as E. Now again draw the reference lines. So let's draw the reference lines, and then the same procedure. So when you draw A, B, so take scale. I'm using the same scale. Pi Newton is equal to 1 centimeter. So here I'm drawing a straight line. A, B is equal to 3 centimeter, then B to C. Sorry, it is an inclined line now. So we have to draw the parallel to that. B to C is 2 centimeter. It's 10 Newton, so it is 2 centimeter. Then there is a any reference point O we have taken. So C to D we are not drawing now because we don't know the reaction. Okay, now just connect these all points. Okay, so once you have done this, now come to the funicular polygon. So now plot the space OA. Okay, take the your ruler here, draw a line OA parallel to the space. This is OA, then OB, there is a B space. Okay, so in this, just draw a line parallel to OB here. Then there is a C space. Okay, so further take it like this. Okay, now you join these lines. Okay, so this is we are closing the polygon over here. This is P, this is Q. Now draw a line parallel to PQ. Okay, from O, we have to draw a line parallel to PQ. Now where it will go? So So it depends where it will go. Okay, so wherever it is, we have to draw it from O point. So like here, it is going like this somewhere. Okay, so the reference lines on the right line only I have drawn. Okay, this is the reference. So like my diagram is not accurate. Okay, so this line may go up also. So you have to just be careful ki you draw it parallel to this. Okay, and to the scale. My diagram is not to the scale. So now what is I feel correct? Okay, this looks parallel to this. So I have drawn it like this. Now you see C to D point. Okay, C to D there is a reaction VQ. So what you do? Draw a here. So this is your D point. C to D. So C to D, what you are getting? C to D, you are getting the reaction VQ. So when you measure this length, you will get the reaction VQ. Okay, when you convert it according to the scale. Now from D to E, there is a reaction VP. Okay, VP is the reaction. So what you will do? E point we have to plot. Again, it is a straight line. So just draw a straight line from here. Straight line we have drawn. Okay. Now from E to A, E E is connected to A, is connected to D. Okay. So what you do? Draw a horizontal because it's a horizontal force, na? So just draw a reference line here. Okay. So here it is cutting at E point. This is the E point. Okay. So now here you can see that whatever D to E length you are getting, that is your VP, and E to A you are getting. This is your HT. Okay, so solve this problem with both the methods, with our analytical method and this method. Okay, and then verify your answer. Okay, you should get the answer. Okay, so thanks for listening. Thank you.